In this lesson, we're going to look at some special cases with absolute value inequalities, as well as word problems. And the specific type of word problems we're going to look at are tolerance. Recall the absolute value is the distance from 0, so it can never equal a negative number. For the less than, these are your and statements. So I have absolute value of x is less than, perhaps it could be equal to, we'll do it equal on this one, to a. So we have two options. Option 1 only works if a is a number. If you have a variable there, you're out of luck. So I would put x in between negative a and positive a. Your second option to solve this, your first inequality would be x is less than or equal to a, so just remove the absolute values. This is an and, so you need the word and in it. And your second one is x, reverse your inequality and take the opposite. On the gray tour, than or equal to. So I have absolute value of x is greater than or equal to a. You only have one option on these. The first one, you remove it as it's written. You include the conjunction or, and your second one is x, reverse the inequality and take the opposite. The first three examples are just review from yesterday. You have to get the absolute value by itself. So I'm going to subtract 3. And then I need to get rid of this 2, so I'm going to divide both sides by 2. And set up our two statements. This is an or problem, and I can determine that at this step. So this is grade tour. You have to get the absolute value by itself before you decide that. So for my first inequality, I have x minus 2 is greater than or equal to 4. Or my second one is x minus 2 is less than or equal to negative 4. On my first one, add 2 to both sides, so x is greater than or equal to 6. Add 2 on this one, so x is less than or equal to negative 2. Remember, this is an or. I'm going to go ahead and graph that. Since my variables are on the left, I can go ahead and use those for my arrows. So at 6, it's included, and it's going to the right. At negative 2, it's included, and it's going to the left. Interval notation, it goes left forever, so that's negative infinity. Remember, your infinities always have parentheses. Comma, stops at 2. 2 is included, so it's a bracket. I need to use the word or, so make sure you include your conjunction. And then it starts up at 6, and it goes to infinity. 6 is included. Infinity will always use a parenthesis. Example 2, you might look at this and go, oh, this is less than, so it's an and problem. However, I do not have my absolute value by itself, which I have to do. So I'm going to divide both sides by negative 2. And when you divide both sides by a negative, remember, your inequality reverses. So this is actually an or problem. My first inequality is 4x minus 1 is greater than 9. I'm going to use the word or. Make sure you put your conjunction in there. My second inequality is x minus 1. I have to reverse the inequality and take the opposite. Add 1 to both sides, so 4x is greater than 10. Divide by 4, and you have x is greater than 2.5. On the other inequality, add 1 to both sides. Oh, this had a 4 on it. And then divide both sides by 4. And so this is x is less than negative 2. Remember, this is an OR. Let's graph both pieces. My x's are on the left, so I can use the inequality as my arrow. So this one's going right. And 2.5 was not included, so open circle. Negative 2, it's an open circle. It's not included. It doesn't have the equals, and it's going left. And for interval notation, it starts left forever, which is negative infinity, to 2. Infinities always use parentheses. 2 is not included. It uses a parenthesis. Include your conjunction, or. Then it starts at 2.5. 2.5 is not included, so parenthesis, and then it goes to infinity. For example 3, the absolute value is by itself. This is less than. So it's an and problem. My first inequality, I have 5x plus 2 is less than 3x minus 4. And my second one is 5x plus 2 is reverse your inequality, so greater than, take the opposite of the other side, so negative 3x plus 4. You have to take the opposite of everything. On the first inequality, subtract 3x. And then I'm going to subtract 2 from both sides. And divide by 2. So I have x is less than negative 3. For my second inequality, add 3x to both sides. So you get 8x plus 2 greater than 4. Subtract 2 from both sides, so 8x is greater than 2. And then divide both sides by 8. I'm not dividing by a negative, so my inequality does not reverse this time. And that will give me 0.25. This is an and statement. So if I look at this, I have at negative 3 open circle, and it's going to the left. And at 0.25 open circle, and it goes to the right. But this is an and statement, so I have to look where they overlap. These two graphs never overlap. So there is no solution on this. If I were to graph it, I would just leave my number line empty. They don't overlap, so there is no solution. We're going to look at some new stuff today, and that's the special cases. So we haven't talked about these yet. When I had the absolute value equal to a negative, there was no solution because distance has to be greater than 0. So on this one, the absolute value here, the smallest this could be is 0. Or it could be larger than that, and it could be a positive value. But the left side is either 0 at the smallest or a positive number. Well, this can never be smaller. 0 is never smaller, nor a positive number smaller than a negative. So when this happens, there are no solutions. So you can save yourself some time if you look when your absolute value is by itself. Is the other side a negative? If it is, you don't have to do any work. If it's equal to a negative, there's no solution. If it's less than a negative, there's no solution. On example 5, the absolute value, so this left side, the smallest it can be is 0. It could be positive, but it's going to be one of those options. And that is always bigger than a negative. So this is always true. So my solution is all real numbers. And to write that in interval notation, you would just do negative infinity, comma, positive infinity. For tolerance, you're going to take the actual minus the ideal, and we want that within some tolerance. An example of this, a food manufacturer specifies for every family-sized box of cereal, you should have a net weight of 25 ounces. So that would be our perfect size cereal. This is our ideal or our mean, with a tolerance of 1.25 ounces. If I buy a box of cereal that's supposed to have 25 ounces of cereal and I get 30 ounces, I'm going to be very excited because I got a really good deal. However, if I open my box and it only has 15 ounces of cereal when it was supposed to be 25 ounces I paid for, I'm going to be mad and think I got ripped off. So the company doesn't lose money and put too much cereal in, or doesn't make their consumers upset by cheating them out of the cereal. They want to have it within a certain tolerance, so it balances the customer being happy with the company not losing money by putting too much in there. So we don't want them to be upset by getting too less of the cereal or putting too much where the company is losing money. So we're going to write and solve an absolute value inequality that describes the acceptable net weights for the cereal of the family size box. So the actual, we don't know. They're going to vary from each box. Minus the ideal, which was 25. And we want that within a tolerance of 1.2. This is an and statement. Since this is a number, if you want, you can just smash it between. So it needs to be between negative 1.2 and positive 1.2 here. And then to solve this, to get rid of a minus 25, you're going to add 25 to each piece. This is an and statement, and I'm using option 1. And let's check and see if our answer really makes sense. So if I look at this on a number line, the perfect box would be 25. And I can do a tolerance above of 1.2, which would give me the 26.2. Or I can go below, and if I subtract 1.2 from 25, I would get the 23.8. So if the cereal box is between those two numbers, everybody should be fairly happy. For example 7, you have found that your new winter coat is comfortable to wear when an outdoor temperature is between 10 degrees and 42 degrees Fahrenheit inclusive. Write an absolute value inequality for this temperature range where T represents the temperature in degrees Fahrenheit. I don't have my ideal. It's in the middle of this. So the mean you just have to find the average. So you're going to just add those together. And so 10 plus 42 divided by 2 will give you 52 over 2, which is 26. If I were to draw a picture of this, 26 is my mean, and I know my lower and upper bounds were 10 and 42. So the distance from 26 to 10 is 16. That's my tolerance. My distance from 26 to 42 is also 16. So to find the tolerance, I could have done 42 minus 26. I could have done 26 minus 10. Or I could have done 42 minus 10 and divide that by 2. So 3 different ways you could find the tolerance. You only have to pick one. They asked us to write an absolute value inequality. So let's go ahead and do that. I have x minus my mean, which is 26, and that's in the absolute values. Tolerance is always less than or equal to. And then my tolerance in this case we found was 16. That will finish this day of notes.